Alright, good night and welcome back to the channel. Today we want to take a look at algorithm. The last time we took a look at IPO chart and we defined IPO chart as being the framework used before writing the algorithm, and it spoke about the input, the output, the processes being used to solve a particular problem. So what we want to do tonight is to touch on what an algorithm is. And first, to understand what an algorithm is, let's look up the definition and see what it says about an algorithm, and then we'll clarify those. All right, so the last time we took a look at the IPO chart, we started off with a problem statement. And of course, we tried to understand what the problem statement was saying. And it read that you would like to be able to write a program that would get the length and width of a rectangular room, and it should be able to calculate and print the area of the room. Now, one of the first things we did, just to touch back on something we did last time, was that we generated something called an IPO chart. And the IPO chart we mentioned consists of input, process, and output. And so we mentioned that some of the inputs that we needed was the one to get the length, right? We also needed to get the width of the rectangular figure or the rectangular room. Output, we know that we would be looking for keywords such as print, and we would print the area of the room. You are also asked to create the process, and for the process, whatever you have in input, you would place into the first line of the process, and whatever was in output, you'd place into the last line of process. And then we would use something to figure out from the problem statement what we needed to do. In this case, it was just to calculate area. I also gave you guys a task. I don't have it here. I gave you a task to go out and try an IPO chart for a specific problem statement, and I'm hoping you did so that you can follow up now with what we're doing today, which is looking at algorithm. So let's start by looking at the definition of algorithm, and I'm getting this straight off the internet, right? So it says algorithm is a process or a set of rules to follow in calculation or problem solving operations, especially by a computer. I don't really like that definition, but it says a lot. It says a process. It says a set of rules. It has the word followed in there, right? It's using problem-solving operations, which is what we're doing. And I like the word computer in there because we're dealing with computers, and the aim of this thing is to move into actual programming. Let's look for a softer definition. Right here, definition by Techopedia. So it says an algorithm is, in its purest sense, a mathematical process to solve a problem using a finite number of steps. Now, that is a little bit more accurate in terms of defining an algorithm. So, process to solve a problem using a finite number of steps. So one of the things we can see about an algorithm is that it is finite, meaning that we have a set number of steps that can be used to solve a problem. In the world of computers, an algorithm is a set of instructions that define not just what we need to be done, but how to do it. Now, this definition I love, right? It is a set of instructions, and I'll use the word finite again. A set of finite instructions that defines not just what needs to be done, but also how to do it. Meaning that we can apply algorithm now to anything in life, right? So an algorithm in its simplest form is basically steps used in problem solving. But we're seeing that the steps should be clear, that there is a beginning and an end, and that means that the steps are finite, right? So algorithm, again, by definition, we could say a set of instruction that defines not just what needs to be done, but how to do it, or a series of steps used in problem solving. Let's make it short and fix one small definition. Set of instructions used to solve a problem. Right? So a set of instructions used to solve a problem. So let's look back at our IPO chart that we did last time, and we can see that our algorithm is actually what is inside the process. Now, there are some methods that we'll use to write algorithm, and I'll highlight those as we go along. But right for today, we will create the algorithm that could be used to get the length and width of a rectangular room and calculate and print the area of the room. And we'll be using our algorithm or creating our algorithm direct from this process. So let me do it below here, and I will call this the algorithm. So one thing for sure, we know that an algorithm contains a begin and an end, or a start and stop. I don't want you to feel like it has to be begin and end. It can be anything that denotes that something is starting and anything that denotes that something is ending. So begin and end is fine. Now, one of the first things we want to do in terms of algorithm is to talk about what the problem statement is, which is this particular description here. So for our algorithm, I'll put a topic or a heading that tells us exactly what the algorithm will be doing. In this case, it'll get the length and width of the rectangular room, and then it should calculate and print the area of the room. So that's our problem statement. So we begin, and normally when we're writing algorithm, we want to tab in so that we can start to differentiate the different parts of our algorithm. So the first step, if I look back at my IPO chart now, which becomes essential, is to get the length and get the width of the room. So we can tell the user, so we can ask the user to get the length of the room, and we can then get length, right? Or read the length of the room. So we can tell the user to get length. Now, what happens here in this statement, and this statement is critical, we call this statement our prompting statement. A prompting statement, if you look at a particular program or at a particular website, for example, let's use Google as an example. When I see a text box like this, the prompting statement here is search Google or type a URL. So the prompting statement actually gives the user, the person using your program, instructions to follow. So although we're seeing a text box, this is actually our prompting statement. Search Google or type a URL, and then you press enter, right? So if we create programs using graphical user interface, our prompting statement is actually the graphical user features that are present on it. So prompting statement, in front of this, let me put the word print. So it'll print out something that tells the user to get the length of the room, and then the user gets length. Now when we have get length like this, that is normally what we called a statement that receives information, or a statement that assigns a value to a particular variable. So it's kind of an assignment statement when we say get length. So what do you think follows now? If we look back at our IPO chart, next step is to get the width. So it's always good to place in a prompting statement, and I'll just copy this so we don't have to write again, that will now tell the user, ask the user to get the width of the room. So you have that right. And what follows is, yep, get width for the room. All right. Next step in our process talks about calculate area. Now remember that in our IPO chart, in the creation of IPO chart, we weren't so interested in how area is being calculated. We just needed to know what needed to be done based on the statement. And the statement says calculate area of the room. So in IPO chart, now in algorithm, we want to know how to actually calculate area of the room. So how do we calculate area of a particular rectangular figure? We take the length, right? We take the length, we multiply it by the width. But we need to assign our values to a particular variable, and so we give our answer to area. Now, notice that I did not write the equal sign, or I did not type in the equal sign, because this is saying, and I'll read it again, it says take length, multiply it by the width of the building, and give your answer to the variable called area. So it's not area equal length times width. It is take length, multiply it by the width, and give your answer to area. So to give to is represented as that arrow pointing backwards to the variable on the left hand side called area. So that settles for calculating area. Then finally, we want to print what the variable area is holding. And so we can put something out that tells the user, again, this is a prompting statement, right? Tells the user that the area of the room is, and let's close quotes here so I don't confuse things. The area of the room is, and it will print whatever the variable area was holding. So that's pretty much it. That's our algorithm. So again, remember that an algorithm is steps that we use to solve a particular problem. We have a beginning point or a starting point. We have an ending point, right? Or a stop point. Now we took or we created our algorithm for the problem statement based on what we did in IPO chart. Now our IPO chart was in this case very important because we got a chance to talk about what the inputs would be. We spoke about what the processes would be, and we also spoke about what the output will be. So writing out our algorithm, one of the first thing we do is to define what our algorithm is, and that's the same problem statement. And then there's a begin. We create a prompting statement that is used to ask the user to get the length of the room. The user then assigns a value to length by saying get length, and then if you're typing in somewhere, then the user enters the length of the room and press the enter key. The user then will see an instruction that says get the width of the room, and then get the width, and we take the length, multiply it by the width of the room, and give it to the variable called area. Next step is that we print what the area of the room will be, and so we print out the variable called area. Notice that when I'm printing out variable, there is no quotations around them, right? But when I just want a prompting statement or a text that I would like the user to see as a part of a program, that is when I would use the quotes around it to specify that I'm dealing only with text. Now, people write algorithm in different forms. I love this one because it brings within it already the prompting statement. So when you transition into actual programming language, it's easier for you to just quickly mimic what the prompting statements are from the algorithm. But if you're doing some reading on the internet, you might see the algorithm written differently without the prompting statement. What do I mean? You might find that the algorithm might be written something like this, where there is no prompting statement in it. Right? Now, this is still correct, right? This still gives you a series of steps that you follow in order to solve a problem. Keeping in mind that the problem that we're solving here is finding the area of the particular building, right? So we begin, we get the length, we get the width of the building, we take that length and multiply it by the width and give the answer to area. and then we print area. So in essence, this is still a complete algorithm. The only difference between this one and this particular one is that this one has in the prompting statement, which then allows you to transition into actual programming very easily. But if you understand the concept that we're just looking at steps used in solving a problem, then writing algorithm becomes easy. Now, creating an algorithm, all you have to do is write out in English sentences how you solve a problem. So if you're asked to write an algorithm of things that you do throughout the day, that should be easy. If you're asked to write an algorithm on how you cook something, that should be easy, right? Keeping in mind that you're being precise, you're being unambiguous, and you're being finite in terms of steps. And unambiguous simply means that you're being very clear that people cannot make mistake, right? So, for example, there is no way I think somebody could make mistake and put in something else other than what is being asked, and the answer will be produced. So I'm hoping this helps. Go out and try the last IPO chart I gave you as a challenge. See if you could create the algorithm for that. And of course, next time we'll take a look at programming before we come back into writing of more algorithm. All right, I certainly hope that this clarified all the questions you have about algorithm and that you're now a step closer to working with your first programming language. So we took a look at the IPO chart in the first lesson, and this lesson we took a look at how we create actual algorithm. I'm hoping this gives you the courage to now jump in to actual programming and find a language that you may be comfortable with or something that you want to try and try and know how to convert algorithm to programming. Of course, we'll do it next lesson anyway, but I want you to start looking ahead. So go write some algorithm, solve some problems, right? If you haven't subscribed to the channel yet, this is a good time to do that. Leave comments below if you have any questions concerning what we covered in this lesson. And like always, be safe, guys, and just go out there and just geek yourself.